Okay, we've got this other example now of a geometric series where we want to express some decimals as a rational number. So we want to convert them into fractions effectively. Now, the aspect we're going to go about this is we're going to use series notation to be able to do it. So for the first one, which is 0.2 repeated, 3 repeated, what we're going to do is we're going to write this down into that sort of format here. So this is going to be 0.23. We're just trying to work out what's happening each time. So then it's going to be adding 0, 0, 2, 3. So we're just adding each repeated element to it to establish the pattern here to 0.000023. And then that would continue onward. So you can start to see the pattern which is developing here. Now let's pull out a few key things from this. We've got our first term, which is 0.23. We can also work out our rate here. Now it's dividing by 100 each time, but what we want to do is we want to put this in a better way for us. So what we're going to do is we're going to put this as 1 over 100 for how we set this out. So we're timesing by 1 over 100, which is the same as dividing by 100. And then lastly, we have our infinite series in this aspect because it does reach a point because we get that repeating fashion here. And so what we're going to do is we're going to set this up as being a over 1 minus r. So now as we set this up, we know we've got 0.2 repeated, 3 repeated. This is going to be equal to 0.23. This is going to be over 1 minus 1 over 100. As we break this down, and I'm going to turn the bottom one into a decimal here just because it helps us in this aspect. We end up with 0.23 over 0.99. Now, this is not rational at this stage because you don't generally have decimals as part of fractions. But we just multiply both aspects of that by 100. We do get this out now. We have 23 over 99. Okay, so that's how we can use a series and converting these repeated decimals into a fraction. So now for the next one, we've got 0.57 repeated. So in this aspect, only the aspect of 7 is being repeated. The 5 is not. So let's again work out our pattern. So we're going to have 0.5 plus 0.07 plus 0.007 plus 0.0007. And that's going to start to continue on now. Now, again, let's pull out our first term. Now, in this aspect, 0.5 is not our first term in this aspect because that part is fixed. And so it doesn't have a part in the series here. So that's not actually our first term. Our first term is going to be the 0.07. So we need to pull that aspect out. Now, r in this case, that's going to be 1 over 10, or if you want, we could put this as 0.1. That might help us a little bit in the next aspect. And then we have our sum to infinity here, which is what we're working out. This is going to be a over 1 minus r. So now let's bring this together. So we're going to have 0.57 repeated. Now, the sum of this is going to be 0.5. That 0.5 needs to be there, but it doesn't form part of the series. Then we're going to add to it this part of the series now. So it's going to be 0.07. This is going to be over 1 minus 0.1. As we work this out a bit further, it's 0.5 plus 0.07 over 0.9. Now, as we expand this, I'm going to convert everything into a fraction here. So 0.5 is a half. Now, this other aspect of 0.07 over 0.9, I want it to be expressed in whole numbers and no decimals. So if I multiply the top and bottom by 100, that will convert both of them into whole numbers. So what I end up with is 7 over 90. And when I add both of these elements together and simplify it, what I end up with is 26 over 45.